Greetings and welcome, friends. Mr. Waddy here. Me and my buddies, we are talking about section 5.8. We were proving things on the coordinate plane with, no, never mind. I was going to say like with Samuel L. Jackson, but I feel like he would, no. That'd be a pretty good movie, like Figures on a Plane. No. Nah, never mind. Let's keep going. Let's pretend that joke didn't happen. Problem 5, place the figure in a coordinate plane in a convenient way. Okay, I'll try to do that. That sounds like something that's worth doing. And explain why it's beneficial, I'm assuming is what the rest of that says. I'm not really reading it because I'm finding a coordinate plane for myself. Oh boy. Oh dear. Let's see. Here we go. Here we go. All right, so 5.8, 5.8, here we go. Coordinate plane, bam. All right, so an isosceles triangle, what's isosceles mean again? Two equal sides. Right triangle, ooh, with leg length P. All right, so here we go. The best way to do that is to kitty corner it with that 90 degree from that right triangle. Right like so. So let's see, I went right like that. Let me draw that line. Oh dear.
Why is the image a ruler, not just like a straight head?
Yeah, that's an interesting point. So let's see. So this is a right angle. What would the coordinates of this point be? 0, P. OP, which is what gamers say when something is an overpowered character or play. OP. All right? And that's when it needs to get nerfed or everything else needs to get buffed. So there we go. This is really a great placement because notice that so many of our coordinates would happen to have zeros in them, and 0 is a great number. It is just the best. Donald Trump would say 0 is the best number you've ever seen. That's what I'm assuming. Except when it comes to like what is in your bank account. Yeah, but when it comes to like multiplication or addition, 0 is just the easiest to work with. They're great people. So let's see, over here, question 7. Now it says, notice, write a plan for a proof. So I've got kind of like, yeah, I'm just like hanging out with someone at lunch. I don't even have a napkin to write down a proof on, but I'm just kind of like walking them through it, you know, talking them through it. So here we go. It says, given the coordinates of these two triangles, prove that they are isosceles triangles. Interesting. All right. Well, what would I do? So it's actually not asking for me to prove these triangles are congruent. Do you guys believe these triangles are congruent?
Yeah.
I think they are too. I mean, I could do that using reflexive property. I could use distance formula for these two. I could show parallelacity for those two. I could use alternate interior angles and prove they are congruent using side angle side. But that's not what they asked me to do. Oddly enough. Although I could do that and then maybe use some nah. I think what I would do is yeah, I mean, you could use some CP/CTC, but I'd still end up having to find out some more. So what I would end up doing is use distance formula for OP and MP, right? Show that they are equal. And are equal, right? And since they are equal, then they would be congruent by def of Kong. So OP would be congruent to MP by def of Kong, right? So that's kind of where I would go with that. And if they are congruent, then triangle, man, drawing these triangles sure is tricky. Triangle OPM is isosceles by definition. All right, so that's probably what I would do, and then you could imagine that if I did that, I would then do something very similar over here. You would probably realize that these were congruent to one another at the same time when you measured them, and so yeah, so I would distance formula, right? Basically the same thing except for the other triangle, right? ON and MN. Right, then use def of Kong to show ON is congruent to MN by def of Kong. And if those are congruent, then the triangle is isosceles by triangle ONM is isosceles by definition. Meh, Khalees. All right, right? So that's kind of the way I would work that. Theoretically, maybe you could have, proven they were congruent, used some CP/CTC, but I think CP/CTC would get us to these being congruent, where I need these two sides that are next to each other to be congruent to conclude isosceles. But you might be able to use that. I mean, if I proved they were congruent, I could have cut this in half and just said then, the other one's isosceles true because it's congruent to the first one. But yeah, there's a few different ways we could have done that, but that's kind of the route that I see as the easiest right now. 11. Oh, place the figure on the coordinate plane. I can do that. I'll even give myself a coordinate plane. Look how fast I'm at drawing these things these days, guys. It's amazing. A rectangle with a length of 5 units. All right, I can do that. And a width of 4 units. So I might as well stick it in the corner of the origin there. So X and Y, let's go up 5. 1, 2, 3, 4, 5. And they didn't give a name for this rectangle, did they? I don't think so. But this point would be 0, 5. This point would be 0, 0. And it's 4 units wide, so go over 4 units. This would be 4, 0. And where would this point be? 4, 5, yeah. And then it says, find the length of the diagonal. Length is a distance, and the diagonal is referring to the connection, the distance across the rectangle from one vertex to another. So I don't know, I would probably work with this one, although they are going to be congruent to each other based on some properties with parallelograms and whatnot later on that we'll be doing. There we go. So if I want to find that distance, what is the distance formula, friends? x2 minus x1. y2 minus y1 squared, all under the square root. And so distance formula, I would have distance here is going to equal the square root of 5 minus 0 squared plus 4 minus 0 squared. So that's the square root of 5 squared plus 4 squared. That's going to equal the square root of 25 plus 16. That's going to equal, what's that? 41. Yeah. Square root of 41, which I do not believe reduces. I think 41 is probably even prime. If we wanted a decimal approximation of it, however, 6.403. 1? Something like that. So there you go. And it's easier to place that rectangle in the corner here, right? Rather than like, right, why would I ever do it that way? Like, have you ever seen someone do that when like fresh tray of brownies and they go and like cut some crazy diagonal shape right out of the middle? Right? That would probably annoy like people who are like obsessive compulsive or something. They'd be like, no, I was gonna draw a parallel line grid of intersecting brownie vertices, right? And like it would just devastate people. But actually, boy, I might give you a problem like that. Maybe at the end of this video, you friends in real life ask me about a brownie. Cutting a brownie problem here.
Well, if we're gonna do that, yeah, actual brownies.
Nah, we'll just imagine brownies. So let's see. In exercise 18, write a coordinate proof. So it says given the coordinates of, what's the question?
Wait, why did it skip like 15 or 16?
I don't know. I asked you guys for the list. Well, we'll go with this. I can look back at it, or I'll show you the answers in a moment then, if you'd like. Coordinates of triangle DEA, as shown, are given to us. H is the midpoint. All right, so that's an MP of DA, and G is the midpoint of EA. They want us to prove that DG, all right, this segment is congruent to EH. All right. That makes sense. All right, let's see if we can do that. So if I want to find the coordinates of H, I could do so with the midpoint formula. So I'm going to say that H is the point. Do you guys remember the midpoint formula? I think I gave it to you yesterday. I believe I did.
It's x and plus x2 over 2. Yeah. And y1 plus y2 over 2.
Right, which I think makes a lot of sense. In terms of formulas, I love this formula because I think it just intuitively makes sense that the x coordinate is the average of the x's, right? Add them together and divide by how many there are. And the y coordinate is the average of the y's. In fact, if I, even like the midpoint formula for a three-dimensional set of points, it's similar as well. You would just find the average of the z coordinates. And yeah, it just works out. It's a lovely little formula, really. I really just highly recommend it. So let's see. So the midpoint between A and D is 0. Oh, wrong color, friend. There we go. I'll do 0 minus 2h all over 2. And for the other one, it will be 2k plus 0 all over 2. All right, so h is going to be 0 minus 2h is negative 2h. Divided by 2 is just negative h. And 2k plus 0 is 2k. 2k divided by 2, those 2's cancel out. I'm just going to get k. So there's the coordinates of my friend capital H there. Negative h comma k. Now, do you guys have a prediction for the coordinates of G? Question.
K.
Ooh. Well, k is a y coordinate.
Wait,
So I'm,
how can the coordinates of H be negative H? Negative K.
because of where it's aligned, it's negative h units over. This entire length was negative 2h units away.
Oh,
So half of that,
it's just a different H.
yeah, lowercase h. Yeah. Lowercase and capital letters and Greek letters usually all mean different things, bottle flippers. So for point G, waka, is the midpoint of those two. So it would be 0 plus 2h over 2 and 2k plus 0 over 2. And so G simplifies to be h comma k. All right. So the reason this is true is just like by definition midpoint and then simplifying are the reasons those things are true. All right. Now they wanted us to show that these distances were equal. So now what do I need to find the distance for? I need to find the distance from D to G and from E to H. So let's do that. So let's do I'll do D to G distance formula. Yeah, we've got h comma k there. There we go. So the distance formula for those two, here we go. This is lovely, lovely. All right, it's going to be h minus negative 2h all squared plus k minus 0 all squared. That's just by distance formula. So let's see, h minus negative 2h, well that's 3h, friends. And k minus 0 squared is just going to be k squared. I can distribute an exponent over multiplication, So this is 9h squared plus k squared, all under the radical. Let's see, I think I can fit my work over here. Let's do EH. I guess so. And for EH, it would be the square root of, let's see, which one do you guys want? Well, yeah, we'll do the 2h minus the negative h, all squared, plus 0 minus k squared. Yeah? You guys tracking this? Everyone's quiet right now. Yeah? All right. 2h minus negative h is 2h plus h. That's 3h squared. And plus 0 minus k is the opposite of k squared. I'm cool if you say negative k, but most mathematicians would say the opposite of k. So let's see. 3h all squared is 9h squared plus negative k all squared is going to be the same as positive k squared, because squaring a negative will make it positive. Let's see, my phone's ringing. Since those two are congruent or equal, then they are congruent by def of Kong.